Okay, so I'm going to do this problem that's on the thermal quiz as well as on the one of the thermal homeworks. It talks about how much energy it takes to boil off 100,000 liters of water and how much mass of each of these substances it would take to produce that much energy. So first we need to calculate the amount of energy to boil off 100,000 liters of water if we start at 293 Kelvin. Now 293 Kelvin is the same as 20 degrees Celsius. And the boiling point of water is 100 degrees Celsius. So that means we need to go up 80 degrees Celsius. That's one of the first energy changes we need. There are two. The second is the phase shift of water, which is in a different calculation that I'll do in a second. So to calculate the energy to raise water 100,000 liters of water 80 degrees Celsius, we'll use the Q equals mc delta T equation. Now, delta T is 80 degrees Celsius. M is our 100,000. But, well, this is in liters. The thing about liters in water is that 1 liter of water is 1 kilogram, so we can just convert that to kilogram. C is 4.18 kilojoules per kilogram per degree Celsius. So that's just our conversion factor. That's the constant of water, the specific heat of water. So plugging in variables, we get Q equals 100,000 times 4.18 times 80. So that would be So that is that many kilojoules. 33,440,000. Now, the thing is, it asks for it in megajoules. Or our conversion factor is going to have to be megajoules, not kilojoules. And mega is just 1,000 kilos. So, or megajoule is just 1,000 kilojoules. So to do that, we just divide this number by 1,000. So we only have 33,000 megajoules. 40. Now, that's the amount. That's megajoules. That's the amount of energy that's required to raise 100,000 liters of water by 80 degrees Celsius up to 100 degrees Celsius. So now it's at the boiling point. We just need to boil it off. That's a completely separate equation, which is pretty similar. The equation is Q equals mL, where L is our the phase shift, the energy of phase shift. So it's the amount of energy that it takes to break all of the hydrogen bonds in water and convert it into gas. Well, Q equals M. We know M is still our 100,000. And, oh goodness. And I previously found the value for L as 2,260 kilojoules per kilogram. So doing this calculation is pretty similar to the last one. Even a much bigger number. That is 226 million. Divide that by 1,000 to get megajoules, because that's in kilojoules. So that's Q equals 226,000 megajoules. So the total energy, and then we have to add these two up to find the total.